we have, ooh, that's me. We have the properties of inverse, sine, cosine, and tangent. So last class we learned about inverses, or refreshed on inverses. And remember that inverses, if you're a one-to-one function, then you have an inverse. So our goal is to change sine, cosine, and tangent into one-to-one functions so we can find their inverse. So what I have here is the graph of the sine function. And remember, with the horizontal line test, if I draw a horizontal line to the function and intersect it more than once, it is not a one-to-one function. So it is very possible to make sine a one-to-one function if we restrict its domain. So the most common interval that everybody else uses, you can choose any other interval, but the most common interval to restrict sine to is the interval -π/2 to π/2. So if we restrict sine's domain to -π/2 to π/2, then sine will become a one-to-one function, which is shown below. This is the graph of the restricted sine function, which is now a one-to-one function. So if I draw a horizontal line through it, I only intersect it once, meaning sine is one-to-one, and also meaning that sine will have an inverse. Okay, so the properties, they're here, but I'll write them out again. The properties for the domain restricted one-to-one sine function, the domain is -π/2 to π/2, and the range is still -1 to 1. And when I say common restrictions, these are the restrictions you'll find in every math book. But of course, you can choose different restrictions and still make it one-to-one. But these are the most common ones to use. Okay, any questions so far?
No.
Why is the sky blue?
Oh, because it's an inverse sine. All right. So now let's go ahead and find its inverse, because sine is now a one-to-one function. So this first part, we're going to start with all the properties of the one-to-one sine function. So everything we just saw above, I'm just going to rewrite. So for our sine function, it was y equals the sine of x. The domain was -π/2 to π/2. And the range is -1 to 1. So those are the properties of our domain restricted sine function. Next, let's go ahead and find the inverse. So remember, we found inverses last class. We're going to run through that same process. So the steps for finding the inverse was step 1, make it y equals the sine of x. Step 2, you interchange the roles of x and y. So this will give you x equals the sine of y. And step 3, you solve for y. So in step 3, we solve for y. Okay, so I'm going to rewrite it. What we have here, x equals the sine of y. And we have to get y out of the sine function. So what could we possibly do to have y by itself?
Divide by sine?
That, sir, would be a sin. I'll show you why. It's funny. If you divide by sine, you're actually dividing by the word sin, which unfortunately doesn't make any sense. It is a good option though, because you are actually stating what every other student in this class was thinking. So don't do this because that's a sin.
Well, I was also thinking like factor, but then
Can't
like,
factor anything out.
Yeah.
So the only way, so you guys remember inverses, right? Remember if I said f composed with the inverse of x, what would the result be?
X.
X. So that's what we have to do here. In order to get y out of the argument of the sine function, we must compose both sides with the inverse function of sine. You're like, oh, how would I have ever known that? You wouldn't have. That's why I'm telling you. So you compose both sides with the inverse of sine. And watch the magic that happens.
Is that because the inverse would technically cancel out like the sine?
Very good. So we're using this same property, right? I guess I should write the other one too. If I had f inverse of f of x, what would the result be as well?
X.
X. So what is the result of inverse sine composed with the sine of y? What's that going to give me?
Wait, is that a y?
That's a y. That's my y, yes.
Then y.
You're going to get y. So we end up with the inverse sine of x equal to y. There you go. And now for, write it as the actual inverse. F inverse of x is equal to the inverse sine of x. And now, what is the domain going to be for my inverse?
-1,
-1, 1.
-1 to 1. And what's my range?
-pi/2, pi/2.
-pi/2 to pi/2. There you go. Those are the properties for the inverse sine function. Now let's look at its graph and find out where on the unit circle the inverse sine function lives. Any questions on this process though? Okay, so here is a graph that contains the inverse sine function and the regular sine function. So if they are true inverses of each other, they reflect or they are symmetric about what line?
Y equals x.
Y equals x. Do those graphs look symmetric?
I don't know.
Yeah.
Yeah, good. Here I have 1 and pi/2. Flip it over, pi/2 and 1. Okay. So, and for the inverse sine function, since we're talking about the unit circle, you mostly just want to reference the range for now, because the range tells us where on the unit circle that inverse function lives. So down below, I actually have the unit circle. Well, we'll make it the unit circle. And the inverse sine function lives from -pi/2 to pi/2. So if I label this, this is going to be -pi/2. This will be 0. And this will be pi/2. So what we're saying is that the inverse sine function lives in the first and fourth quadrant. So the only radian values that belong to the inverse sine function, if I'm in the first quadrant, is going to be pi/6, pi/4, and pi/3. And of course, any angles in between. But I'm only putting unit circle ones that we can see on the unit circle. And if we're in quadrant 4, well, you just reflect all these over. Here you'd have -pi/6, -pi/4, and -pi/3. So this is the exact area on the unit circle where the inverse sine function exists. Okay. So that being said, remember that when we use the unit circle, if I said, what's the sine of pi over 4, you'd give me square root 2 over 2. But now, since it's the inverse, we're going to have to go the opposite way. If I say, what is the inverse sine of square root 2 over 2, you now have to give me a radian value. So what would the inverse sine of square root of 2 over 2 be?
Pi over 4.
Pi over 4. So the original way, you put in a radian value, you put in an angle, you get out a numerical value. Now the new way with the inverse, you put in a numerical value and the output is a radian value. So we're still calling on the unit circle, but now with inverses, I guess we can say we're calling on it backwards. So we used to do angle, numerical value. Now we call on numerical value and we spit out an angle. Okay.
What if
So-
say you were to put in like the angle?
And then we would just punch it in a calculator. Because we would have to change it to a decimal, to a number.
Okay.
So even if you did plug in, pi over 4 there, we would just have to consider that an actual numerical value instead of an angle.
So I couldn't consider, say, pi over 4 went into there. I couldn't consider that square root of 2 over 2.
Exactly.
Okay.
You would get something totally different.
Super trippy. I have more questions, but I feel like they'll probably be answered later on.
Well, another thing to notice is that, okay, since we're dealing with the inverse, remember when you plug numbers in here, you're plugging them in for x. Well, what is the domain of the inverse?
-1, 1.
So you can only plug in numbers between -1 and 1 in order for it to work. So that's why when you plug into an inverse function, it has to be considered a numerical value because those values have to be between -1 and 1. Ah, mind blowing, right? All right, of course, more practice. Whoops. So that is the area in which the inverse sine lives. So make sure to reference this for the rest of these notes and for your homework.
How did you get the quadrant 1 and 4 out of that?
Well, what is the range?
-1 to 1.
The range.
The pi over 2, negative pi over 2.
Good. So the reason we're in quadrant 4 is because we start at -pi over 2, which means that would be a negative angle, which means you go clockwise. So you can only exist in quadrants 1 and 4.
But if you were to go clockwise, wouldn't that be like the other way around?
So remember, negative angles go clockwise. So that'd be -pi over 2. Because that's where you start. But then since we go to pi over 2, we have to go back this way.
Okay, I got you.
We don't
Okay.
belong anywhere over here.
So that would have to be like a -pi or a pi value.
Exactly.
Okay, that makes sense now.
Okay. All right. Now important. So I always say this big paragraph is me yelling at you. The inverse sine is not the same as 1 over sine. What function does 1 over sine belong to?
Cosecant?
Secant or reciprocal?
Cosecant. So 1 over sine is cosecant. That is not the inverse. Do not make that mistake. The 1, the -1, is just a notation that expresses the inverse trig function. Another way you may see an inverse written is with the word arc in front. So there's going to be arc sine, arc cosine, arc tangent, and arc of the other 3 functions. So if you have a Casio, I hate them, you'll see arc sine, arc tangent. If you have a TI, you'll see this inverse. Way better.
And so when you plug that in, that's why it finds the angle for you, correct?
Exactly.
So it will output like a radian value, but like in pi over 4?
Mhm.
Oh, okay, cool.
All right, just make sure you are in radians.
Yes, sir.
Okay, so to evaluate the inverse sine function, we use compositions like we did. So with this statement, theta equals the inverse sine of x is the same as x equals sine theta. So if I were to show you how that happens, it'd be the inverse sine of x. Theta equals the inverse sine of x, and then I would compose both sides with sine. And what would the right side cancel out to?
X.
X. That's where that equivalent statement comes in. So this is telling us how we are going to find exact values of inverse sine functions. Okay, I'll leave that up. Why not? All right. Unit circle time. You should be looking at your unit circle. Maybe I should copy and paste it in there. Why not? That won't take long. Oh, not one that I wrote on. Let me see. There we go. Copy and paste. Bam. There we go. Okay. So this says find the exact value of the inverse sine of 1. So the way we handle this is we'll say let theta equal the inverse sine of 1. Then if we compose both sides, so I'll say then, once you do the composition, you should get sine theta equals 1, which means we want to know what radian value makes sine equal to 1 on these restrictions, negative pi over 2 to pi over 2.
Pi over 2?
Good. So this means if you looked at the unit circle, and remember, we're only looking at the first and fourth quadrant. So the only radian value that can make sine equal to 1 on this unit circle for the inverse sine is pi over 2. So what we say is then that theta is equal to pi over 2. There you go. And that's how you handle those. All right, let's try it again. Let theta equal the inverse sine of negative 1/2. Then compose both sides with the inverse, and you'll get sine theta equals negative 1/2. And we have to find the right value of theta on the inverse sine's restrictions, negative pi over 2 to pi over 2. So in quadrant 1 and quadrant 4, which radian value will give me negative 1/2?
11 pi over 6?
But remember, it has to be,
Negative pi over 6.
there you go, negative pi over 6.
So in this, like, okay, so the way you showed it before is how it will always be said because it starts at negative pi over 2?
Exactly.
Okay, got you.
So stating 11 pi over 6 is technically not wrong, but 11 pi over 6 is not in the restrictions of
It's
negative
not,
pi over 2 to
it
pi over
goes,
2.
like, around the restrictions.
Exactly.
Okay, gotcha.
Maybe I should have copy and pasted the other ones. I don't think I can though.
Just copy and paste like with
Let me
the
see.
with the other one's values.
I know. I'm trying to see. I would have to actually make that into a picture, so I don't think it's possible. But let's see.
I believe in you, sir.
Believe in me.
Mhm.
Dun, 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 dun. Let's see. I got all that, and I can say cut. Nope, don't want to do that. How about just copy? I got an idea. So I can get rid of this. One moment. Get rid of
Oh.
these. One moment.
That was a
And
nice little
now-
pregnant stick.
Yeah,
there.
pregnant stick man.
And then paste. All right, there's this. All right, I'm almost got it. Let me see. Shapes. I can do this. How's that gonna work out? Hey, that works out just a little bit. It's a little off, but it's okay. Again, you'll see what I'm doing in a moment. And make it. There we go. Okay. And now one more thing. Bam, look at that.
Mhm.
Pretty for
How's that? Oh, pi over 4 is gone. Hang on. I don't think I need, actually, I don't need that part though, right? Oh, there we go. Get rid of all that. Boom, 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 boom. All right, good. Good to know. Okay. There's that. That's what we're referencing. The only thing that's not on there are the coordinates, but you guys should know that by now. Okay.
You certainly ingrained it into our heads.
So the next one says the inverse sine of 1/3 and the inverse sine of negative 1/4. Well, if you look on your unit circle, do you see any numerical values, numerical, not radian, that are 1/3 or negative 1/4?
Nope.
No. So all we're going to do here is punch it into a calculator. That's all we can do. So go ahead and find those inverse sine buttons on your calculator. I don't have my TI apps anymore, so I'll just use Desmos. Let's see, hide video, hide that, and make sure you're in radians, bam. And I'm just gonna type in the inverse sine of 1/3. And we'll do this to 2 decimal places, why not? The inverse sine of 1/3 gives me approximately 0.34. And then the inverse sine of negative 1/4 gives me negative 0.25. There you go. So you put in a number, you get a radian output. Okay. Cool. All right, any questions on that page? Okay. Let's keep working. And remember the inverse properties. So it says Remember that the inverse composed with f of x will cancel out to x for all domain in f, and f composed with the inverse will also cancel out with x for all x in the domain of the inverse. So what we're going to talk about here is when you compose two functions, remember that whatever function you're composing with, you have to take that domain's function. So this is what we're stating here. We're going to call these properties. This is going to be property 1. This says when you compose the inverse with the sine function, the one-to-one restricted sine function, they're going to cancel and give you x. But when you compose these two, you must abide by the domain of the inside function. And remember, the domain of the restricted sine function is negative pi over 2 to pi over 2. So this means that when we compose these two, we're going to get a radian value. We're going to get an angle. We have to make sure that the angle fits in this domain. If it doesn't, then we'll fix it. And I'll show you how to fix it when we get to a problem like that. Okay. Property 2. This says when you compose the sine function with the inverse sine function, you must abide by the domain of negative 1 to 1. So this means we are abiding by the domain of the inverse sine function, which is negative 1 to 1. So whatever output we get has to fit in between negative 1 and 1. And since this is numerical, if you're out of the restrictions, say we got a negative 2, you're out of the restrictions and we cannot fix, only because it's numerical. You can't fix numerical, but you can definitely fix radian. You can fix the angle. Okay. And of course, we'll make sense of all of this. Start with number 1. You have the inverse sine of the sine of pi over 8. Does this follow property 1 or property 2?
Property 1.
1.
Property 1. So the functions would cancel and leave me with what angle?
Pi over 8.
Pi over 8. Now the question we have to ask ourselves is, does pi over 8 fit in the interval of negative pi over 2 to pi over 2? And if you're
Yes.
wondering
No.
Yes.
if you're wondering what this funny little symbol is, this means belongs to or element of.
Is that like an E? Or
It's a funny looking E. It's
Oh,
supposed to look like that. Okay.
looks like
Like
a
a
T,
squid.
but without the.
Does that have
it's the element symbol.
Hmm.
Okay. So I guess I can, man, I need that thing again. Because where do you think pi over 8 is?
before pi over 6?
Good. It's in between 0 and
Pi over
pi
2.
over 6. I'll show you in a second. Let me get this thing again. Copy. And I'll paste it out here. Paste. There we go. And voila. Look at that. Expert now. Okay. So does pi over 8 belong in there? And yes, pi over 8 is going to be right here. So we're good. So pi over 8 fits in there. So that's our answer. So we can get rid of the question mark.
So if there's a question like this with the homework, are we just answering like, yes, it belongs in there? Or are we actually trying to convert the angle of this or whatever?
So if it doesn't fit in there, then we must convert it. Like I said, we'll get there in a second. Okay. So B, sine of the inverse sine of 0.5. Which property does this follow?
2.
Second.
The second one. So this will give us 0.5. And we want to know, does 0.5 belong in the set negative 1 to 1? Does 0.5 fit in there?
Yeah.
Yes.
Yes. Done. That's easy. All right. C, inverse sine of 5 pi over 8. Does that belong to property 1 or property 2?
Property 1.
Property 1. All right. So they'll cancel and give you 5 pi over 8. We want to know, does that belong to this interval? What do you guys think?
No.
No.
No. Where is 5 pi over 8?
Just past pi over 2.
Yeah, it's gonna be a little bit over a half.
It's going to be right there. It's going to be 5 pi over 2. So, like I said, since it doesn't fit, but it's an angle, sorry, not over 2, 5 pi over 8, we can fix it. And the only way to fix this is by reference angles. So how many pi over 8s is it going to take me to get back to the x-axis?
3.
So it'd be negative 3 pi over 8.
So it's going to take me, remember, reference angles are always positive. So to get from 5 pi over 8 to the x-axis, it's going to require 3 pi over 8. And now, does 3 pi over 8 fit in the interval of negative pi over 2 to pi over 2?
Yes, but how does that work? Because it's still outside of the.
Yeah, because I thought it was gonna be like, like the 180-degree version,
Yeah,
the negative
yeah, me
quadrant.
Mm-hmm. So good. That's a good question. So 5 pi over 8 doesn't fit, but its reference angle is 3 pi over 8 will. Because guess what? 5 pi over 8 and 3 pi over 8, remember, if you're a reference angle, you share the same numerical values. And lucky for us, sine in the first quadrant and sine in the second quadrant will always be what? Positive or negative?
Positive.
So this is why it works. So we say that 5 pi over 8 does not fit in that set, but the reference angle,
The angle with the same values.
of 3 pi over 8 fits in negative pi over 2 to pi over 2. So again, if it's an angle, we can always fix it.
So if we always see one of these problems that we're using part 1, can we always just say it's yes because we could always fix it without actually trying to solve it?
I think it's going to make you solve it. It's going to make you find that reference angle.
Okay, gotcha.
Yeah. All right. And then last, sine of the inverse sine of 1.8. Is that property 1 or property 2?
2.
2.
That's property 2. So you'll get 1.8, and we want to know, does it fit in the interval negative 1 to 1?
No.
No. And we can't do anything about that, guys, because it's numerical.
So it's not valid, is essentially.
That's it. We cannot compute. If you have your calculator out on you, type in the inverse sine of 1.8 and tell me what it gives you.
What, catch on fire?
It might.
Explode.
Just combust.
All right. I'm assuming none of you have your calculator in front of you. So cool.
Yeah, it says
right.
error domain.
There you go. It's a domain error because 1.8 is bigger than 1. So it doesn't fit in that interval.
Will it ever be like on part D, will it ever be instead where the inverse and the sine are flipped, but it's still going to be a numerical value?
Ah, good. So if it was inverse sine of like sine of pi?
No, if it was like inverse sine and then parentheses sine of negative 1.9 or 1.9.
Oh, 1.8.
Yeah.
And we would want to know, does 1.8 fit in negative pi over 2 to pi over 2? Ah, I see what you're saying. Well, I guess we would have to get the decimal values for pi over 2 and see if that fits. No, you wouldn't get anything like that because that's just brutal.
Bar.
1.8. Yeah. Because that means you'd probably be in quadrant 2 and we could fix it, but no, you wouldn't get that yet. Don't worry, I'll show you how to fix those ones later on. Okay. All right. So that's everything about the inverse sine function. Make sure to know where it lives. Make sure to know what radian values you get. Any questions on that? All right, then. Next up is the inverse cosine function. So just like sine, cosine's not one-to-one. So we make it one-to-one by restricting its domain. The most common restriction to use is from 0 to pi. So if we restrict cosine's domain to 0 to pi, we end up with the graph, which represents a one-to-one function. So we restrict cosine's domain. It is now one-to-one. Okay, so for cosine, the restricted cosine, our domain is 0 to pi, and our range is still -1 to 1. Okay, so now since cosine is 1-to-1, cosine is going to have a what?
Inverse.
Inverse. Yeehaw. So let's go ahead and do the same thing we did for sine. Let's go ahead and put the information for cosine here. So y equals the cosine of x. Its domain is 0 to pi. Its range is -1 to 1. And now let's find the inverse. Step 1, y equals the cosine of x. Step 2, interchange, x equals cosine of y. 3, we solve. And when we solve, we compose both sides with the inverse. So you'd have cosine inverse of x equal to cosine inverse of the cosine of y. And what's going to happen on the right side?
Cancel, leaves y.
Cancel and leave y. And there you have it, guys. Same exact thing. 4, write it as the inverse. F inverse of x is the inverse cosine of x. And now, what is my domain and range?
Domain -1 to 1.
-1 to 1. Range is
To pi.
there you go. And now just focus on the range because the range tells us where we live on the unit circle. So here is the graph of cosine and its inverse. Those look symmetric?
Yeah, that looks trippy.
Yeah, that's really weird looking.
Mhm.
Looks pretty cool, right? It's like
Yeah.
one of those stingrays, right?
Something like that.
Yeah.
Seeing like a dragonfly or something.
Okay, fine. Use your imagination.
Bow and arrow.
All right. So there you go. It's pretty symmetrical. Those are the graphs. And now let's focus on the important part, the unit circle. So where does the inverse cosine live?
0 to pi.
0 to pi. And let me do this so I can copy and paste. Let me see. Do that and do that. And do, nope, you're not doing it. Nope, not that one. Stop it. There we go. There we go. Then move. Bam. All right, cool. Okay. So we live from 0 to pi. So this means the inverse cosine lives in which quadrants?
1 and 2.
1 and 2. And now let's talk about the radian values that are in quadrants 1 and 2. First quadrant's easy. Pi over 6, pi over 4, pi over 3. Now what's left in quadrant 2?
2 pi over 3, 3 pi
3 pi over 4.
4, 5 pi over 6.
Good. And anything else in between, right? There you go. That is where the inverse cosine lives. Any questions on that? And let me do my magic over here. Let's see. Bam. Perfect. Okay. So once again, this is me yelling at you. Remember that the inverse cosine is not equal to 1 over cosine. What function does 1 over cosine belong to?
Secant.
Secant. Good. So 1 over cosine is secant, which is not the same as the inverse. Good. Okay. And again, to get to this statement, you would do the compositions. We've seen it before, so we know how to do it. Also, you may see inverse cosine or you may see arc cosine. Just another way to state the inverse. Okay. So we are going to do the same exact thing we did with sine. We're going to call in the unit circle. We're given a numerical value and we want the output of a radian value. So the steps for that is again, let theta equal the inverse cosine of 0. Then you'll compose both sides with the inverse, which would give me cosine theta equal to 0. And now we ask ourselves, what radian value on the interval 0 to pi will make cosine 0?
Wouldn't that be pi and 0?
Cosine at pi and cosine at 0 is what value?
Pi over
Okay,
2.
that's 1, no, pi over 2.
Good. So theta would be pi over 2. Because cosine of pi over 2 is what value?
0.
0. There you go.
So cosine, inverse cosine at 1
Would be 0.
it
And
wouldn't-
inverse cosine at -1 would be
okay, I got you. Yeah.
would be pi, right?
Yes, sir.
All right. Oops. Let theta equal the inverse cosine of negative square root of 2 over 2. Then compose both sides with the inverse. And we ask ourselves, what radian value on the interval 0 to pi makes cosine negative square root of 2 over 2?
3 pi over 4.
3 pi over 4. Good.
I don't know how you guys memorize this.
I have it right in front of me.
They have it
literally
right in
not
front of them, Ethan. My goodness.
No, I like memorize the entire game.
I'm trying to memorize it.
Just have it out in front of you. That's how you do it. You reference it and you know it.
But if you memorize it, then you know it for good.
I have a poster of it on my wall.
There you go. Tattoo it on your forearm.
Just like those
Every time.
those conic values, right? Conic rules.
Oh my goodness. All the formulas.
You're
All
like, I
right.
know everything.
Any questions on this? Keep doing it. It's repetitive. So now you know, right?
So is quadrant 3 never going to get any love?
Probably with tangent. Wouldn't that be like quadrant 1 and 3?
No,
No,
quadrant 3 will get no love.
Oh. Don't hurt me.
All right. So again, here we are with the inverse properties. So we're going to have property 1 again, which deals with the angles. So if we have inverse cosine with cosine, we have to make sure the angle fits in the restriction 0 to pi. And then property 2, if you compose cosine with the inverse, then we make sure that we'll get a numerical value that we have to make sure it gets in between -1 and 1. Okay. And let's see. Do I need to copy that again? Sure, why not? Let me do it. There we go. And bam. There we go. Okay. So first up, inverse cosine with cosine of pi over 12. Is that property 1 or property 2?
1.
That's 1. So we're going to get pi over 12. And we want to know, does it belong to 0 to pi? Where is pi over 12 at?
Between 0 and pi over 6.
Oh, yeah. Good. So this is where pi over 12 would be. So does it fit in that interval?
Yeah.
Yes.
Yes, we're good. Nothing else to do there. Okay. And then B, cosine of the inverse cosine of -0.4. Property 1 or property 2?
2.
Property 2. So you get -0.4. Does that belong in the interval -1 to 1?
Yeah.
Yes.
Yes. Perfect. All right. C, the inverse cosine with cosine of -2 pi over 3. Which property is that?
1.
Oh, no.
1. Good. So you'll get -2 pi over 3. And we want to know, does that fit in 0 to pi?
No.
Yeah.
No. Where is -2 pi over 3 at?
Quadrant 4. No, that's quadrant 3, right? Yeah.
So
3 because 2 pi over 3 is quadrant 2.
Quadrant 4?
Yeah.
Or quadrant, oh,
yeah, you're good. Because this would be -pi over 3, right?
that's what I was thinking.
So reference angle we get.
So -2 pi over 3. So it does not fit, but we can fix it. How many pi over 3s in reference angles do we need to get back to the x-axis?
Pi over 3.
Just a pi over 3.
And it's always going to be positive, right?
And it's always positive. All right. Well, actually, in this case, it's going to be tricky because since we're in quadrant 3, cosine is what?
Negative.
Negative. So even though we're going to say pi over 3, the actual answer should be what?
Negative pi over 3.
Mm-mm.
Oh, no. Oh, 2 pi.
2 pi over 3, because in quadrant 2, cosine is also what?
Negative.
Negative.
That's tricky. I like that.
Can you explain? I'm confused.
Yeah, one more time on that one.
Like super tricky.
Okay. So in quadrant 3, everything's negative, right?
Yeah.
But in quadrant 2, cosine's negative and sine's positive. So if we actually wanted to use the correct answer of -2 pi over 3, well, at -2 pi over 3, cosine's negative, and at pi over 3, cosine is not. Because over here, cosine's what?
Positive.
Positive.
Oh,
So if we actually wanted the technically correct answer, we would have to use what?
2 pi over 3. And that's because it's like the same value just with a negative.
Exactly. Because 2 pi over 3 and negative 2 pi over 3 share the exact same x value because they both are what?
Well,
Positive.
Negative.
yeah, negative. Oh, yeah, yeah, negative.
All right. But here, there's a big or here. Or, right? Or, get this. I'll rewrite this. Cosine inverse of cosine of negative 2 pi over 3. Here's where it might make more sense. What do you guys remember about cosine? Is cosine even or odd?
It's even, right?
Mm-hmm. It's even. So what's another way I could rewrite the inside?
Cosine of 2 pi over 3.
Cosine of positive 2 pi over 3. And that's only because cosine is what?
Even.
Even. And then you'd get 2 pi over 3. And does that belong to 0 to pi?
I believe it.
Yeah.
Ding, ding, ding.
That's so weird.
So that's actually our true answer. So if you put pi over 3, it's going to be wrong because negative 2 pi over 3 and pi over 3, yes, they have the same x value, but negative 2 pi over 3, the x value is negative. Positive pi over 3, the x value is what?
Positive. So you just need to make it a negative.
Positive. Ugh, mind blowing, right? You guys good with that?
Yeah, we need more of them like that.
No, let's just stick to the simple arithmetic stuff.
All right. So then next is cosine of inverse cosine of pi. Property 1 or 2?
2.
Property 2. So this means we get pi and we want to know, does it fit in negative 1 to 1?
Isn't it kind of like that brutal one where you can't?
Well, pi.
Well, actually, no, because it equals 3.14, so it doesn't, right?
Yeah.
There you go. Here we have to treat pi as a numerical value. So since pi is 3.14, does it fit in those brackets?
No, sir.
No. So we're done. Can't do anything about it because we're treating it as numerical.
So in that previous one, remember I told you, you're like, oh, it's brutal. You would just have to treat that pi in that radian value as 3.14 and just figure out whatever the decimal place would be.
No, because you had it the other way. You had it using property 1.
You had it cosine of negative pi and then in parentheses.
Yeah, because you made it become 1.8, which means it's actually a radian value that would be in quadrant 2, and we would have to figure out how to get it back into quadrant 1. So that one would be nasty. But again, you can fix it, but that's not till next class.
Oh, till calculus?
No, next class.
Next
Thursday.
Period.
Thursday. Once you get to calculus, you're already expected to know all of this, and that's it. Don't worry, you guys will forget it. I still ask my calculus class. I'm like, okay, so we get to this answer. What is the cosine of pi? And there's a long silence. I'm like, it's okay, guys. I know you forgot everything. It's okay.
I honestly feel like this is just like
so
into my brain.
I'll tell you something though. Cal 1 is not too heavy on trig. We'll use enough trig, but nothing crazy. Cal 2, your trig comes back heavy, real heavy. So when we get to 8.4 identities, you guys are going to want to remember that section because identities come back in a huge way in Cal 2. So just saying.
You said you're not doing Cal 1 next in the fall?
I have it in summer. I wasn't able to pick one up for the fall because.
So are we just like barely scratching the surface on trig right now?
No, we're learning everything about trig. But again, you go to Cal 1, you kind of use it, and then once you get to Cal 2, you kind of forget it. So I'm just saying, just refresh on it. Save your notes.
Remember before.
Because you're gonna get something you're gonna get a antiderivative that says take the antiderivative of cosine to the fourth. And in this class, we actually make an identity of cosine to the fourth. So don't forget your notes. Okay. Just showing you how everything's connected. Yes, I understand we forget things because we go from class to class, but as long as you have your notes on you, something to reference, you should be fine. Okay. So that was everything about the inverse cosine function. Everybody good?
Yes, sir.
All right. We lost some people when I said Cal 2. They're dropping off. All right.
Like, not today, Satan.
Like, nope. Okay. So now we come across the third inverse function for today. We're going to look at the inverse tangent function. And of course, even though there's vertical asymptotes, if I draw a horizontal line through tangent, I intersect it infinitely many times. So to make it a one-to-one function, we choose the same restrictions as sine. We are going to restrict tangent from negative pi over 2 to pi over 2. But unlike sine, these values will not be included because what exists at pi over 2 and negative pi over 2?
Asymptotes.
Asymptotes. So for tangent, it's only going to be between negative pi over 2 and pi over 2, not included. So if we do these restrictions, tangent becomes one-to-one.
So even though you can draw a horizontal line through at all those points, it's going to have even more restrictions than sine?
No, it's sharing the same restrictions. The only difference is that the domain is parentheses negative pi over 2 to pi over 2.
Not brackets. Gotcha.
Not brackets. Okay. And those are the properties of the tangent function, the restricted tangent function. So again, like all the others, let's run through finding the inverse. Start with the properties first. Y equals the tangent of x. The domain is negative pi over 2 to pi over 2. The range is negative infinity to infinity. And let's find that inverse. Step 1, y equals the tangent of x. Step 2, x equals the tangent of y. Step 3, compose both sides with the inverse. So inverse tangent of x is equal to the inverse tangent of the tangent of y. And we know what happens from here. The left side becomes x, and not x, sorry. The left side becomes tangent inverse of x, and the right side becomes y. So 4, write it as the inverse. Inverse of x is equal to the inverse tangent of x. And what is my domain and range now?
Your domain is negative infinity to infinity, and your range is parentheses, not brackets, negative pi over 2 to pi over 2.
There you go. Okay. So if you're trying to remember inverse restrictions, just remember that inverse tangent and inverse sine have the same restrictions. The only difference is tangent is not included. Here are the graphs of the function. So there's your inverse tangent, there's your tangent. Do those look symmetrical?
Yep.
Yes.
There you go. What's it look like now?
Like a box.
Like a crab or a plant?
Think of making a snow angel in the Texas snowstorm.
There you go.
Can't touch the asymptote.
Okay. So what we have, let me see, so I can take this with us, is we exist again, it's just like sine. We exist in quadrants 1 and 4. But you cannot use negative pi over 2 or pi over 2. We can go 0 and everything else. Pi over 6, pi over 4, pi over 3, flip them over, negative pi over 6, negative pi over 4, negative pi over 3. And that's where the inverse tangent function lives. Bam. And paste. Nope, didn't want to do that. Okay. Cool. And me yelling at you again. The inverse tangent is not the same as 1 over tangent, because what does that belong to?
Cotangent.
Good. 1 over tangent is cotangent, which is not the same as inverse tangent. You can find another similar statement as arctangent. Okay, so once again, let's do it all over. We're gonna find the exact value of these trig expressions, these inverse trig expressions. So we let theta equal the inverse tangent of 1, then compose both sides, and you'll get tangent theta equal to 1. And again, we ask ourselves, what radian value makes tangent equal to 1 on the interval negative pi over 2 to pi over 2?
Pi over
And
4.
what radian value would that be?
Pi over 4.
Pi over 4. Good. And then again, let theta equal the inverse tangent of the negative square root of 3. Then compose both sides and you get tangent theta equal to the negative square root of 3 on negative pi over 2 to pi over 2. So what radian value lets tangent equal to negative square root of 3 on the interval negative pi over 2 to pi over 2?
It's either negative pi over 6 or negative pi over 3, but I don't know which one.
Negative pi over 3?
Because I'm trying to do it all in my head right now. It's not working.
Negative pi over 3. Because what are the coordinates at pi over 3?
At pi over 3, you have 1/2 and then 3 pi over 2.
Well, square root 3.
I mean,
2,
square root of 3
right?
over 2.
Well, here it would be negative because it's that. And then tangent puts negative square root of 3 over 2 over 1/2. Which you'd multiply by the reciprocal, bam, bam, and there's your negative square root of 3.
There we go.
All right. Okay. Cool. So those are the properties of inverse tangent. All good?
Yes, sir.
All right. Those are the inverse properties, but we're good with that. So we know how to work those. Let's move on.
1 and 2.
All right. Find the inverse of a trigonometric function. So here it says find the inverse function of f of x equals 2 sine x minus 1, where the domain is negative pi over 2 to pi over 2. Find the range of the original function and the domain and range of the inverse. Okay. So let's find out what we know. So I'm going to write the original function here. 2 sine x minus 1. And the only thing we know right now is that the domain is negative pi over 2 to pi over 2. All right. Yeah. So anybody have an idea on how to find the range of this function?
Find the inverse's domain.
All right, find the inverse. I'm down with that. So if you find the inverse's domain, then you find the original function's range, right?
Yes, sir.
All right, genius. Okay, so let's go ahead and do that. Let's find the inverse. And of course, the steps are the same. 1, y equals 2 sine of x minus 1. Step 2, interchange. X equals 2 sine of y minus 1. And then step 3, solve for y. So what are we moving over first?
You move the
The
one
one?
over, and then you can take the inverse, right?
Almost.
Well,
Almost.
you move the 1, then divide the 2, and then take.
Oh,
Good.
yeah, that's right. So
Move the 1 and then divide the 2. And then apply what to both sides.
inverse sine
Sine of negative 1. Or inverse
or
sine.
arc sine.
Inverse
Yeah,
sine.
arc.
Inverse sine. And this will equal y, right?
Yes.
Okay. So now write it as the inverse, and we get the inverse sine of x plus 1 over 2. And now, oh boy. What is our, do we even know what our domain would be for this?
You would make 0 equal to 2, and that's not true, right? So
No.
no.
Well, do you know the range?
I know the range. Negative pi over 2, comma pi over 2.
Negative pi over 2 to pi over 2. Okay. So, oh man. So in order to find the domain of this, we thought it was going to be easy, right?
Nah, come on.
Well, remember that the domain of the original inverse sine function is negative 1 to 1, right?
Yes.
That's what we learned today, right? So if y was the inverse sine of x, the domain was for negative 1 to 1. Well, now, if we have something other than x, this means that we're going to have to trap it between these restrictions. So what do we have inside these parentheses?
X plus 1 divided by 2.
So we're going to trap this between the restrictions negative 1 to 1. And we're going to solve for what?
X.
X.
I don't know how to do that. All right, you got me.
So wait, does that just mean you're gonna like throw a value of like 0 in there?
No, not doing anything. We're solving for x. You guys ever solved a double inequality before?
I have never solved a double anything before.
Excellent. Learning new stuff.
Maybe I don't remember.
Well, basically, what you're going to do, whatever you do, affects the left and the right side, and of course, the middle. So if we're going to solve for x, how do we get rid of that 2?
Or
So you're gonna multiply both sides by 2.
Multiply
Or all
both
three
sides by 2.
Oh,
And
all
you'd get-
3 sides by 2. Then I guess you could say.
Multiply all 3 parts by 2. Oop. And you'll get negative 2 less than or equal to x plus 1 less than or equal to 2. And then you'll subtract
1 from every side.
from every side. And what is my restriction now?
-3
-3 into 1.
less than or equal to x is less than or equal to 1.
There you go. There's your domain. So how would you put that in interval notation?
Wouldn't that just be like -3?
Bracket -3 and then comma 1 bracket.
There you go. Oh my goodness.
That's trippy. Oh man, I'm so
That's
glad-
cool, but where did you learn to solve a double inequality? I don't think I've ever learned
I've
that.
never, ever, ever
Business
done that.
math.
Like, I've never even seen that before. I knew
Yeah,
it
I'm
was
saying
awesome.
I
We-
don't remember
we-
that going through that in all of high school or any of that.
We use them in business math.
Man, that's cool. I'm glad I know how to do that now.
Oh, it's funny though. They're not called double inequalities anymore though.
What are they called now?
I forget the name. It's funny. Double inequalities. Let me see.
I'm honestly very intrigued. I learned something like way.
Yeah, that's kind of.
Oh, they're called compound inequalities.
Oh, I mean, yeah, because like that final thing is a compound inequality, and I've seen compound inequalities before. but I
Yeah.
didn't-
I've never known them as compound until I started tutoring people outside of the school. And they're like, yeah, my high school's trying to solve compound inequalities. I was like, what the hell is that?
talking
See,
about-
that name's familiar. I just don't remember like solving for that.
Isn't that like algebraic?
Yeah, it's algebraic, but of course it's however you learned it. Maybe you never learned it. Maybe it's the first time seeing it. So there you go.
So there's
never,
nothing
like,
special for it. It's
Hearing
literally
of like
just
being able
like a
to do
regular
operations.
inequality or equation, except you just do it to both sides.
Exactly.
And are you gonna flip the? Are you still gonna flip the
The sign
inequalities if
only
divide by negative?
if you divide or multiply by negative.
Okay.
Okay. So this means we know what the range is.
-3, 1 in brackets.
-3, 1. But guys, we knew the range all along before doing that complicated thing. What is the range of the original sine function?
-1, 1. in
What does
brackets,
this 2 do in front?
multiply?
Making the range what?
Multiply by 2.
Good. So if the
But that's like
original
the same thing
range,
as the compound inequality. which
yeah,
I've
if the
never done
original
before.
range is -1 to 1, and then you multiply it by 2, you get -2 to 2. But then what do you do with that -1?
Subtract or
And
add.
you get -3 to 1. There you go. You think about
so
it.
you can literally use transformations.
You
to
can
solve
think
that.
of transformations to get the range. You stretch it by 2, so it's -2 to 2, and then you subtract it by 1. You drop it down. So now it's -3 to 1. But you see how many options we have here. They all work the same.
This is legitimately blowing my mind.
Yeah, same, dude. Like same. I'm like,
Love it.
that's great. It like, man, that was very enjoyable.
Jessica's
Good.
drooling right now.
She's probably done. Her brain exploded. All right. Math is everywhere, even in the afterlife. Nice. All right. Everybody good with that one?
Yes.
All right.
Oh, she's dead.
Yep. Hey, millennials spell it DED. Okay. All right. Last page, I think. It's just solving trig equations. Yes. So our job is to solve for x. So this one says solve the equation 3 inverse sine of x equal to pi. Our job is to solve for x. So what would you divide by first?
3.
3. We'd get inverse sine of x equal to pi over 3. And then to get x out of the argument of the inverse sine, you would
X.
apply what to both sides?
Sine.
Sine. So
Sine.
x equals sine of
X equals sine of pi over 3. Now look at your unit circle. And what is the sine of pi over 3?
1/2. 1/2?
Mm,
No.
mm,
Yeah. Sine, right? Sine all the way out.
Gilbert, you have it pulled out.
Uh,
No,
square,
because pi over 6.
3 square
is 1/2.
over 2. Yeah,
There we go.
Ooh.
Square root 3 over 2.
I put it down for a second.
There you go. Luis's brain just fried. All
Yeah.
right.
Hey, it's back. It's back. We're good. All right.
Everybody good with that?
Yes, sir.
All right. Another one. Same thing. What do we divide by?
4.
4.
And the
Inverse
same
sine
thing
of
multiplied by
x
sine.
equals pi over 4. You don't multiply, you compose.
So sine or x equals sine of pi over 4, which is square root of 2 over 2.
You sure?
Yes.
There we go. Okay. And then here, same thing. Divide by what?
3.
Cosine inverse of 2x equals 2 pi over 3. Then compose both sides with
Cosine.
Cosine.
cosine. And you get cosine of 2 pi over 3. And what
They
is the
still divide by
cosine?
2.
What is it?
You divide by 2 from
Not yet.
Right
What's
of
the
it.
cosine? I mean, we could, but I'm waiting because what's the cosine of 2 pi over 3?
the cosine of 2 pi over 3 is
Negative
the
1 over
cosine
2.
of pi over 3, just negative, right? So the cosine of pi over 3 is 1/2, so negative 1/2.
Yes. Full circle. And then divide by 2 and you get what?
Negative 1/4.
Yeah.
There you go. All right. Last one. Oof, that one looks ugly.
Ooh, this looks fun.
4 inverse cosine of x minus 2 pi equals 2 inverse cosine of x. So remember that everything is algebraic. Do you see any like terms?
Cosine of negative 1.
It's the inverse cosine, not cosine of negative 1.
Inverse cosine of x.
Inverse cosine. So could you combine these two terms together?
I don't know.
Yes.
Yes.
Well,
I just subtract inverse cosine of x, subtract 2 inverse cosine of x, and you get 2 inverse cosine of x minus 2 pi equals 0. Like I said, everything's algebraic, guys.
Then plus 2 pi.
And then move the 2 pi to the right. Divide
You
by,
want to do the, oh, do you want to do the divide by 2? Oh, yeah, because if you divide by 2, then it's just
yeah,
pi.
we can't compose yet until you get the inverse all by itself.
Oh, if it's on the inside, if it's 2x on the inside, then
Yeah, but that 2 is on the outside,
Yeah.
right?
you still have to get rid of that. Okay.
So then x equals cosine of pi.
Negative 1.
Yeah,
Negative
negative
1.
1.
There you go. Fun stuff, guys.
Ooh, that was a fun lesson today.
Chapter 8's great.
Yeah,
You're gonna
definitely like
learn,
better than chapter 7.
you're gonna learn like
I like
40
chapter 7.
formulas.
I mean, I didn't enjoy the first parts of that, but that last part of the equations is fun.
Yeah, like where we got to like actually graph it and stuff. Yeah.
Complementary angles, reference angles, all boring, right?
No.
But it's either easy, but that one part that 2 pi over 3 it threw us off. That thing just like it's just weird. It's like you have to really think outside the box. So it's
Oh,
just
on
weird.
the other
Well,
page.
And
Yeah.
then
Yeah,
and then
the even property or whatever it is. A bit
I
difficult.
guess like the reason I understood it so quick was because cosine negative anything is just cosine of whatever it is
Yes,
without the negative.
because it's even.
I explained that so bad, but y'all get it, okay?
All right. Well, that finishes 8.1, guys.